Hello, this is Algebra 1. We're doing Polynomials Notes 2, during which time we will be talking about expanding on FOIL, superFOIL, a personal favorite, and then finally some special binomial product patterns. Let's get started. Here we have expanding upon FOIL. As you can see, there's two methods, method 1 and method 2, that allow you to do a problem like this. I do strongly suggest that you read through this first, but I won't bore you by talking about the things that are already written on the page. Here's an example of what I'm talking about. Now for these examples, I'm going to go ahead and use what was listed as method 2 in the first piece there. See here. So we begin by foiling it out. Makes x squared plus 3x minus 4x minus 12. Then we'll go ahead and clean up our foiling. That plus 3x minus 4x goes ahead and makes minus 1x. The 5 is still sitting on the outside. And then the 5 can distribute in, makes 5x squared minus 5x minus 60. Okay, let's go on to the next example. Here, you'll notice it's squared, so we'll go ahead and first write it out as 3x plus 2 times 3x plus 2 because of the squared. Notice that the negative 2 is still in front, waiting for its action. Now, again using method 2 as described on the prior page, it's foiled out. Go ahead and clean up the foiling. You can see my handwriting is becoming a little more gargantuan as we move along. No reason for that really. And then finally distribute the negative 2, so it makes negative 18x squared minus 24x minus 8. Wonderful. Alright, that was just expanding with a little number in front as extra product fun. This is superFOIL. This is quite possibly my favorite part of all of Algebra 1. There should be not one but several comic books about the adventures of superFOIL. But you really should read this. It's excellent reading, I know, because, well, I wrote it. And then, once you're done reading it, let's go ahead and start these problems. Here's the first one. Now the fun business here is that each part in the first polynomial, in this case it's a trinomial because it has 3 terms, but each part in the first polynomial has to multiply by each part in the second polynomial. I've tried to color code it for you. Eventually the colors become a little ugly, I'm afraid, but hopefully that will work for you. And then once you're done, go ahead and collect the like terms, and we get our answer. Now again for the next one, that 2x distributes across the entire second polynomial, then the 3y does, and finally negative 2 distributes across the entire second polynomial. Now we can go ahead and collect like terms. So made 6x squared plus 1xy plus 0x minus 12y squared plus 17y minus 6. There's a couple problems here. That 1xy is a little silly looking. The 0x also. So just for, well, good form, I'm going to rewrite it for you. But in this case, the step above would have counted as a correct answer also. Alright, now I want to give you a chance to try these on your own. So again, as always, please pause the video and try number 1. I'll wait a few seconds so you have a chance to pause it. When you unpause it, I'll still be here waiting for you. Okay, hopefully you paused it enough to try number 1. Here's the answer. So first of all, I've foiled it all out. There we go. Now collected up the foiling, and then finally distribute that 7. Good times. Alright, for number 2, again, I'm going to wait a few seconds, so please pause the video, try number 2 on your own, and then I'll still be here when you come back to check your work. Alright, so first, notice that it's 2x minus 5 times itself because it's squared. Now if we FOIL it all out, and clean up our foiling here, and then finally at the end distribute that 4, so everybody gets to play with the 4. Okay, let's go ahead and look at the next one. Again, please pause the video. I'll wait a few seconds for you. I want you to try number 3 on your own first. So I'll wait. I'll still be here when you get back. Okay, hopefully you tried number 3 on your own already. And let's see how this works out. Well, oopsie daisy, there we go. Distributing everything, superfoil style. Now this one's kind of long. And then cleaning up the like terms. Creates our answer. It's good fun, but I'll tell you what's better. Number 4. Number 4 is pretty awesome. So again, I'd really like you to try it on your own first. I'll wait a few seconds so you can pause the video. And after you've tried number 4, I promise, I'll still be here. Okay, hopefully you tried number 4 on your own. Let's see what happens. Alright, so it's 5x minus 8y plus 3z, but it's multiplied by itself because of the squared. So foiling, that 5x multiplies by each of the pieces in the second polynomial. Now the negative 8y multiplies by each piece in the second polynomial. And finally 3z multiplies by each piece in the second polynomial. Then if we clean up by combining like terms, it's a little tricky because you got to keep the variables straight, but if you're super careful, you'll be able to notice what goes with what. And there's our answer. Alright, that's it for superfoil. Now we have some special binomial product properties that we need to learn in Algebra 1. They're mostly shortcuts. So first of all, we have this thing called perfect squares. And there's a special pattern at the bottom here in orange, and it should be in orange in your note sheet as well. It's super important for what we're doing right now. Let's do a couple examples here. So first of all, x plus y squared. So notice the x and the y. Now, there's a middle term, we call it that, 2xy, and that's because it's twice the product of each of the pieces. This is the funny business with the square pattern. And in this case, it's actually a pretty boring example because nothing exciting happens. I just wrote it again, all in the same color. But I promise you, this next example, it'll get a little more interesting. Let's see. Alright, the pieces are 2x and negative y, so it's 2x squared, and then minus 2xy, and then plus y squared. Notice that middle piece is always 2 times the first term times the last term. So the 2x squared makes 4x squared. Then if you multiply everything together in the middle term, it's minus 4xy, then plus y squared. This is getting pretty complicated, but it does save us a lot of time over foiling. Let's see the next one. So 2x and 4 are the pieces. So the first piece squared, and then double the first term times the second term, and then finally the second term squared. And then if we clean it up, 2x all squared is really 4x squared, because the 2 gets squared also. Then 2 times 2 times 4 is 16. There's also an x. And then 4 squared is 16. Okay, now, this last one, kind of the same as the one before, but it's got a minus. Also has c's and d's. So the first piece is 2c. The second piece is 4d. So it's 2c squared. 2 times 2c times 4d. This one's minus in the middle though because there's minus in the problem. And then plus 4d all squared. Alright, so 2c squared is really 4c squared. And then negative 2 times 4 is negative 16 cd. And then 4 squared is 16, so 16d squared. Okay. Now, that's great for perfect squares. Not simple at all. And I'll be honest, if you're looking at a test and if you can't learn this pattern, you can always cheat and just FOIL your way out. But if you learn this pattern, it will save you some time. So I know it's kind of a chromatic explosion on your page right now, but if you look at it a little more carefully, you might be able to save yourself some serious time. Now there's a second one, which is actually much easier to do. It's called the difference of squares. I want you to read about it. It's pretty good writing, I know, because, well, I wrote it. But most importantly, it's when you have the same two binomials multiplied together, but one with a plus and one with a minus. That's good stuff. Oopsie daisy, excuse me. I got all excited there. All right, now let's do the first one. So it's x plus y times x minus y. So actually it's just super fast. It's x squared minus y squared. The first thing squared minus the second thing squared. Boom. Okay, now for the second one. The first thing is 2x squared minus the second thing, which is y squared. 2x squared is really 4x squared and y squared. And we're done. Okay, the next one. The first thing is 2x, so we'll square that. And the second term is 4. We'll square that. This pattern only works, of course, because they're the same thing in both binomials, just one is plus and one is minus. Alright, so 2x squared is really 4x squared, and 4 squared is 16. Done. Boom, 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 done. Alright, the last one of my examples for you. The first term is 2c, so it will be 2c squared. The second term is 4d, so it will be 4d squared. 2c squared minus 4d squared. Alright, if you square 2c, you get 4c squared. If you square 4d, 16d squared. Okay, got a few for you to try. Now this time though, I want you to notice what kind of pattern it is first, and it tells you at the top. Your choices are perfect square or difference of squares. Once you've noticed that, then try to use the pattern to make the expression come out nice and neatly without actually foiling. So look at 5. Hopefully by now you've already noticed what kind of pattern it is. It's a perfect square. Now, using that information, please go ahead and try to simplify the expression yourself. Go ahead and pause the video. I'll still be here when you get back after you've tried it. Okay, welcome back. So c plus d squared is c squared, 2cd, and d squared. And since they're just simple variables, there's nothing more to do. Alright, now look at number 6. Please look at the problem. Hopefully by now you've noticed it's not a perfect square. It's a difference of squares. Knowing that, please go ahead and pause the video. Try it yourself. When you unpause it to check your work, I promise I'll still be here. Okay, let's see what we got. C plus D times C minus D. It's just C squared minus D squared. First term squared minus the second term squared. All right, now we have number 7. Type of pattern first. Hopefully you've already noticed it's a perfect square. Now that you know that, please go ahead and pause the video. I'll wait for you. When you've tried it and unpause the video, I promise I'll still be here. Welcome back. It was m minus 2n squared, so it's m squared minus double m 2n plus 2n squared. Okay, knowing that, we can go ahead and simplify out the pieces. M squared minus 4mn plus 4n squared. Okay. Last one for this whole set of notes. Number 8. Please look at it. Try to figure out which of the types of patterns it is. And hopefully you've already noticed it's a difference of squares. Now that you know that, go ahead, pause the video. I promise I'll still be here after you've tried number 8. Pause the video, try number 8, then come back. Hey, welcome back. Number 8, let's see how it works out. M minus 2n times m plus 2n. M squared minus the 2n term squared. So it's really m squared minus 4n squared. Okie doke. That's it for these notes. Hopefully you've noticed how you can superfoil, how you can cheat the amount of work for foiling by using perfect squares and differences of squares. Basically, it makes foiling extra fun. Thanks for watching. Let me know if you have any questions.